Hi class, this is Sir Alex again. Welcome to our lesson in General Physics 1. Today we'll be doing some of the practice problems that I've uploaded in your LMS, the lesson 3.5. This is a combination of all the lessons in lesson 3, namely the uniform motion and acceleration, free fall, and projectile motion. Today I'll be helping you guys understand what is happening on these questions, on these simple problems, as well as how to approach them and how to solve them using the kinematics equations that we have discussed throughout this entire lesson. So let's begin by doing sample problem number 1. We'll be focusing first on displacement velocity as well as uniform motion and acceleration. I've included the kinematics equation here on the right side, and let's see on how we can use these and apply them to sample problems. Okay, so the sample problem 1 reads as, how fast will an object in motion along the x-axis be moving at 10 seconds at t is equals to 10 seconds if it had a speed of 2 meters per second at t is equals to 0 seconds, so there should be a seconds here, and a constant acceleration of 2 meters per second squared. So let's begin by writing our given. So for these problems, we were given that the speed of the moving object is 2 meters per second, so its velocity is equals to 2 meters per second, and this is the velocity at time is equals to 0 seconds. What that means is that at the beginning of time in this simple problem, its speed is 2 meters per second. You can think of that, what it means is that it's the initial velocity of the object. So the initial velocity of the object is 2 meters per second at t is equals to 0 seconds. And what it's asking, or also, it is given that the acceleration of the object is 2 meters per second squared. We were also given a time of 10 seconds. But what is this 10 seconds? This 10 seconds is basically related to the question being asked. So what it's asking is that what would be its velocity at 10 seconds? So I hope you can kind of like see what is happening. So the initial velocity, or the velocity at t is equals to 0 seconds, is 2 meters per second, and it's accelerating for at the rate of 2 meters per second squared. After 10 seconds, what would be its velocity is basically what they're asking. As for formula, I've already written the formulas here. So let's begin with the solution. So how are we going to approach this question? So first they're asking for velocity, and we know that velocity is equals to distance over time. However, we do not have any distance from our given, but what we have is we have our initial velocity and we have acceleration and time. So from all the given information that we have, among all the equations that we have, the only equation that all of these belongs to is actually the first one. So they give us the acceleration, they give us the initial velocity, and they give us time. What we are looking for is basically the final velocity, or the velocity after 10 seconds. So we will have to use that equation. Acceleration is equals to final velocity minus the initial velocity divided by time. And since what we are looking for is the final velocity, we have to arrange this equation. So we will have the final velocity is equals to acceleration multiplied by time plus the initial velocity. So after finding these equation now, what we just have to do is basically substitute all the values. So what we have is final velocity is equals to the acceleration, which is 2 meters per second squared multiplied by how much time? It's just 10 seconds plus the initial velocity given to us, or the speed of the moving object at t is equals to 0, which is 2 meters per second. So you can cancel that. You will left with one s over here. So 2 meters per second plus 2 meters, or 2 meters per second multiplied by 10, that's 20 plus 2. That would give us 22 meters per second. So that would be our velocity after 10 seconds. So if we kind of draw this at t is equals to 0, the car is moving along the x-axis, and this is time is equals to 10 seconds. So at t0, the velocity of the car is 2 meters per second, but it's accelerating at the rate of 2 meters per second squared. So at t is equals to 0, it's already 2 meters per second. Then it keeps accelerating at this rate, and afterwards, when it reaches the time of t is equals to 10 seconds, the velocity is already 22 meters per second. So that's basically what they're asking, and that's how you solve sample problem number 1. Okay, next let's move on to sample problem number 2. We're still in displacement, velocity, uniform motion, and uniform acceleration. So this question is a little interesting, so let's read it. A car is rolling towards a cliff with an initial speed of 15 meters per second. The maximum negative that the brake can provide is negative 0.3 meters per second squared. If the cliff is 350 meters from the initial position of the car, will the car go over the cliff? So let's kind of like draw what is happening here. So basically you have a cliff. So you can kind of like draw it this way. And you have a car here. So if this car went over the cliff, it will surely fall, right? So from problem that we have, we know, so let's write our given, that the initial velocity of the car is 15 meters per second. So the car is moving at the rate of 15 meters per second. And the maximum negative that the brakes can provide is negative 0.3 meters per second squared. So what this is actually a acceleration, but it's on the negative. Remember, acceleration is a vector quantity, so it has a direction. This negative sign means it's going in the negative direction. If the velocity is going to the left, as this arrow suggests, the acceleration, on the other hand, is going towards, or this velocity is going to the right, the acceleration it has is going to the left, which gives it a negative 3 meters per second squared. It gave us that negative sign. What this means is it's basically deceleration. It is slowing down the speed of the car. And this is what you want, because if you keep speeding up, you're gonna end up falling into the cliff. So what you want is to decelerate the car by giving it a negative acceleration. So the acceleration is negative 0.3 meters per second squared. This is the maximum deceleration that the car's brake can provide. And the initial position of the car and the edge of the cliff, this distance is 350 meters. So the distance that we have is 350 meters from the initial position of the car to the cliff. So the question that they're asking us is, will the car go over the cliff? So basically, will the car fall? So how can we measure this type of question? Well, we just have to analyze it. How can a car flow? The only possible answer for that is if the car went over the 350 meters distance between the car and the cliff. So if the car went over, let's say, at 351 meters, it will surely fall because and it will not fall if it is less than 350. So what they're basically asking us is actually the distance. So in other words, as the car decelerates, how far does the car have to go from the initial position until it stops? So how can we solve this? Well, basically, let's look at our equations and determine which equation do we have to use to solve for the distance that the car will stop. So from all of these equations, let's first look at displacement because that's the equation that we have. We're looking for displacement. So from all the given, we are given the acceleration and we are given the initial velocity. And what we are concerned about as well is that the assumption that we are looking at dx at the moment that the car's final velocity will be equal to 0 meters per second. So the time that the car will stop. So at what distance will the car will stop? So meaning the final velocity should be 0. So looking at the equations, the only equation that we have that we can use is actually this one because it has the dx, it has the acceleration. Moreover, it has the final velocity which we want to be 0 and we have the initial velocity. So let's head on to the solution. Okay, so let's write our equation. 2a dx is equals to the final velocity squared minus the initial velocity squared. So again, what we're looking for is the distance that the car will stop, wherein the final velocity would be 0. So we can just remove this as 0, and we are left with 2a dx is equals to the initial velocity squared. And since we are looking for the distance, so that will give us dx is equals to, this should be negative, minus or negative vo squared divided by 2a. So let's substitute our value. The initial velocity is 15 meters per second squared divided by 2, and the acceleration that we have is negative 0.3 meters per second squared. So plugging that in your computer, you will be able to get that the distance that the car will stop is 375 meters. So let's answer the question, will the car fall? The answer is, will the car go over the cliff? The answer would be yes. The reason that it is yes is because it will stop at 375 meters. However, the distance between the car's initial position and the edge of the cliff is 350. So by the time it reaches the edge of the car, it has not fully stopped. The velocity is not yet at 0 meters per second. Therefore, the car will fall. Okay, so that's how you approach this type of question. Okay, I hope that is clear. If there's any problem or things that are unclear, please message me so I can clarify more about this problem. Now let's head on to sample problem number 3. We're still in displacement, velocity, uniform motion, and acceleration. Okay, so we have cart A moves with a uniform speed past point 1 on a straight track at 0.3 meters per second, while cart B moves past point 1 at 0.1 meters per second but is uniformly accelerating at 0.1 meters per second squared. Point 2 is at is 1 meter past point 1. Which cart gets to point 2 first? So let's kind of draw what is happening in this type of situation. So we have point 1. And points 1, the distance between point 1 and point 2 is 1 meter. And we have cart A and we have cart B. When cart A passed point 1, its velocity is 0.3 meters per second. So the velocity, you can treat this as the initial velocity at point 1, and that is 0.3 meters per second. While point B, when it passes point 1, it is at a speed of 0.1 meters per second. So the initial velocity of cart B is 0.1 meters per second. Cart A is basically in uniform velocity. That's a uniform speed, meaning the speed is not changing. While cart B is at a uniform acceleration. So meaning it is the speeds is increasing at a constant rate of 0.1 meters per second squared. So the question that they're asking is which cart will get from point 1 to point 2 first? Will it be the cart A or will it be cart B? So let's write our given. So the initial velocity of cart A at point 1 is equals to 0.3 meters per second, while the initial velocity for cart B is equals to 0.1 meters per second, and the acceleration of cart B is equals to 0.1 meters per second squared. The distance between point 1 and point 2 is equals to 1 meter. So what they're asking us is which cart will arrive point 2 first. So how are we going to ask this type of question? Let's analyze this. So what they're asking us is, again, which cart will arrive at point 2 first? The only way that we can measure this is basically by time that they arrive is the time that they arrive point 2. So as they travel from point 1 to point 2, how long will it take for cart A to arrive from point 1 to point 2? The same way. So basically the time for cart A and basically the time for cart B. How long will it take for cart B to arrive from point 1 to point 2? And whichever has the lowest time means they arrived at point 2 first. So let's do our solution by solving for the time it took them to arrive from point 1 to point 2. Okay. So let's begin with cart A. So we were given the initial velocity of cart A. We were given the displacement, how far cart A traveled. And what we're looking for is the time. Sorry. And we know that cart A it's a uniform motion. Therefore, cart A acceleration is actually 0 meters per second squared. So that's another assumption. Remember, uniform velocity means the velocity is not changing, meaning the acceleration is 0 meters per second. So since we are looking for time, they gave us the initial velocity, they gave us the distance they traveled, they gave us the acceleration. Well, they not gave us the acceleration, we were able to assume the acceleration of cart A. So from these equations, we Using all the information given, we will have to use this because it has the displacement, it has the initial velocity, it has the time, as well as the acceleration. So for part A, we will have to use dx is equals to the initial velocity time plus 1/2 at squared. But remember, our acceleration is 0, so we can remove this as 0 because a multiplied by a is 0. Any number multiplied by 0 is equals to 0. So basically what we have is dx is equals to vot, and we are looking for time. And time in here is basically the initial velocity divided by the distance traveled. So time is equals to the initial velocity of cart A, which is 0.3 meters per second, divided by 1 meter. And that would give us time is equals to oh, sorry, this is mistake. It should be dx over vo. Sorry about that. So distance is 1 meter over 0.3 meters per second. There you go. So 1 over 0.3 is actually equal to 3.3 seconds. So it took cart A to arrive from point 1 to point 2, 3.3 seconds. So let's solve for the time it took cart B to arrive from point 1 to point 2. Again, from all the given equation or information that we have, we will still have to use the same equation. So dx is equals to vot plus 1/2 at squared. Okay. Only this time we cannot remove this part because a has a value which is 0.1 meters per second. So let's plug in the numbers. So we have 1 meter. So the distance cart B traveled is 1 meter. So let's just write 1. 1 is equals to the initial velocity of cart B, which is 0.1 t plus 1/2 of its acceleration, which is 0.1 t squared. So rearranging that, we would actually get 0.5, 0.05. Yeah, that should be 0.05. 1/2 of 0.1 is 0.05 t squared plus 1.1 t is equals to negative or minus 1 is equals to 0. So from here on out, as you can see, this is actually not a perfect square. So what we have to use is use the quadratic equation. Use quadratic equation to solve for time. And for quadratic equation, it will give you two numbers, negative and positive. So just plugging it, you can use the internet to find a quadratic equation calculator. Just plugging in this is your A, this is your B, and this is your C, -1. Just plug in those numbers in your quadratic equation calculator. You'll be able to get two t's, one that is negative and one that is positive. And let's take the positive, and t is actually equal to 3.6 seconds. So it took cart B to arrive from point 1 to point 2, 3.6 seconds. So the shorter time is cart A, which is 3.3 seconds. So the answer would be cart A. So that's how you would solve this problem. Cart A took only 3.3 seconds shorter than card B, which is 3.6 seconds. So therefore, which card will get to point 2 first? It would be card A. This would be your answer. Okay, I hope that is clear. If you guys have any questions about sample problem 3, again, do not hesitate to message me. Okay, so that is for displacement, velocity, uniform motion, and acceleration. Now let's head on to our free fall. So this is our sample problem 4, and now we are dealing with free fall. The same way with uniform motion and acceleration, the equations or the kinematics equations for this problem are already written here on the right. So let's try and use and see and apply which equation we have to use to solve for our problem. But before that, remember that for free fall, the acceleration for free fall will always be g, which is negative 9.8 meters per second squared, because our acceleration for free fall will always be going down. And we were also dealing with the y-axis. So for uniform motion acceleration, we are mostly dealing with motion along the x-axis, but for free fall, we are dealing with motion along y-axis. So we are going up or going down from our point of origin. Okay, let's read the problem. A ball is released from a window at t is equals to 0. Assuming free fall conditions, which means we neglect air resistance, how far does it travel in 2.8 seconds? If the ball had more mass, would it fall at a greater distance? Okay, so let's try and draw this. So we have a window. Let's see, we have a window right here. And let's have someone here. And they drop a ball. So they drop a ball from a window, and the time here they drop it is basically t is equals to 0. At t is equals to 2.8 seconds, they're basically asking how far did it travel. Okay, so let's write our given. So first we are given time is equals to 2.8 seconds, and we did the time, how far does it travel? So what they're asking is distance. Okay, remember for free fall, the point of release, the area, the point where you released it to fall down or to throw it up, we can treat that as our origin. So in this case, the window would be our origin. So from the point of origin, we're basically going down. And remember our configuration, anything that is below the point of origin should be on the negative sign. Okay, let's look at our equation now to see which equation we have to use to solve for this problem. So we are looking for displacement, and from here, let's see whether to use 1 or use number 2. Well, what we're looking for is dy. Well, we have dy here. They can both solve for dy. But unfortunately, at this time, we are not, it was not said that at 2.8 seconds, that it finally was on its final velocity or it ended. So we cannot use the second part. But you may think, how about the initial velocity? They did not give us the initial velocity. Well, you can assume the initial velocity because when the ball dropped, it was not said to be moving anyway. So the initial velocity of the ball at the beginning is 0 meters per second. Because the ball would just be there, it was being held held, it is not moving, and when it is released, so the initial when it was released, it was not yet moving until it was released. So the initial velocity of the ball would be 0 meters per second. And they gave us the time as well, which clarifies more that we cannot use the second part, because in the second part we do not have time. But for for the first part, they also gave us the time. Okay, so what that means is we have to use the first equation for displacement, which is equals to dy is equals to the initial velocity time plus 1/2 gt squared. Again, the initial velocity is 0, so we can basically remove that. That would give us dy is equals to 1/2 gt squared. So 1/2, the only acceleration we have here is acceleration due to gravity, which is negative 9.8 meters per second squared. That would give us time, which is at 2.8 seconds squared. As you can see, s squared, that's cancelled. This is cancelled. We're left with meter, which is what we want since we're looking for displacement. So plugging in your computer or in your calculator, we will get that the answer would be negative 38.4 meter. So the answer is 38.4 meter. As you may have noticed, it is negative, and that is because it is going down. So the distance is negative because it is going down the point of origin. But in the end, ultimately, your answer should be 38.4 meters. Okay, so that is the answer for problem number 4. Now let's move to our second problem in free fall, sample problem 5. Determine the distance between two steel spheres after 1.4 seconds dropped from a tower if the second sphere was dropped 0.5 seconds after the first. Question: free fall and that the spheres are dropped from rest. Okay. Determine the distance between the two steel spheres dropped from a tower. So we have a tower. So let's draw a tower. And from the tower, we dropped two steel spheres. Okay, so the first after 1.4 seconds. Okay, so that means is the first steel sphere. So we have sphere number 1. So this is our sphere number 1. And then our sphere number 2 was dropped at 0.5 seconds after the first. So what that means is we drop sphere number 1. After 0.5 seconds, we drop sphere number 2 and then counted 1.4 seconds. And we are measuring the distance between the two spheres. The initial velocities for both sphere is 0 meters per second. Okay, so that is the question being asked. Let's write our given. So for given, the time we were given us is 1.4 seconds. Moreover, the velocity initial for both sphere is 0 meters per second. The sphere, two spheres drop 0.5. So, what do you call this? So the time between the two spheres that they were dropped is 0.5 meters per second. So sphere 1 and sphere 2. Okay, So this is the time difference between the time that they were dropped. Okay, and what they're asking us is distance between the two spheres. Okay, so how are we going to solve this? Well, if we are going to analyze, let's draw this again. So sphere 1 was dropped first, and after 1.4 seconds, sphere 1 had traveled a distance of something. We do not know it yet. While sphere 2 was dropped 0.5 seconds after sphere 1. So what that means is it traveled at less distance after 1.4 seconds. dy is equals to here. We do not know yet. And what we're looking is the distance between the two. To identify this, what we just need to do is first measure the distance traveled by sphere 1, and then measure the distance traveled by sphere 2, and then basically subtract the two so we can find the distance between the two spheres. So that's what we're going to do. So let's begin by solving for the distance for sphere 1. So how far did how far did sphere 1 traveled after 1.4 seconds? So the initial velocity of sphere 1 is 0 meters per second, and the time is 1.4 seconds. Remember as well, for free fall problem, our acceleration would always be g. So we know the a, we know the time, and we know the velocity. And from here, we are basically solving for dy, the distance traveled by sphere 1. We have this first equation because we have the g, we have the time, and we have the initial velocity. Okay, so dy for sphere 1 is equals to the initial velocity multiplied by time plus 1/2 gt squared. So the initial velocity would be 0, so let's remove that. That gives us 1/2 multiplied by negative 9.8 meters per second squared multiplied by 1.4 seconds squared. So we will be able to cancel the seconds, and that would give us the distance traveled by sphere 1 is negative 9.6 meters. Again, it's negative because the point of release is on top of the distance traveled. So everything below that should be negative. So we have negative 9.6. How about sphere 2? Well, another thing that you have to notice is that sphere 2 was dropped 0.5 seconds after the sphere 1. What that means is that it did not travel the whole 1.4 seconds. So we have to minus the time. 1.4 seconds minus 0.5 seconds. So what that means is sphere was only in the air for 0.9 seconds. So that was the time for sphere. Because when sphere 1 was dropped, we were measuring the time it dropped at t0 to t 1.4 seconds. But sphere number 2 was dropped not at t is equals to 0, but t, okay, let's try that. But t is equals to 0.5 seconds. So there's a difference between the time. So you just have to minus the 2. Then we get that the sphere 2, the second still sphere, was only in the air for 0.9 seconds. Again, because it was dropped 0.5 seconds after the sphere number 1. So let's measure the distance traveled by sphere 2, which we will use again the same equation, plus 1/2 gt squared. Again, the initial velocity of sphere 2 is also 0 meters per second. So ty is equals to 1/2 multiplied by negative 9.8 meters per second squared multiplied by 0.9 seconds squared. So for sphere number 2, it only traveled for negative 4.0 meter. So for sphere number 2, it only traveled for 4 meters as opposed to sphere number 1. So what is the distance between the two? Well, you basically have to subtract the distance traveled by sphere number 1 to the distance traveled by sphere number 2. So 9.6 meters minus 4 meters is equals to 5 meters. So sphere number 1 and sphere number 2, the distance between them is 5.6 meters. Should be 5.6. So that is for sample problem number 5. Okay. So I hope that is clear. If you guys have any questions about these, please message me so I can clarify sample problem number 5. Now let's move to sample problem number 6. So here there's quite a lot happening in sample problem number 6, but let's all get through it. Okay. So a rock is dropped from a garage roof from rest. So we have a garage. So if we can just draw this one, so let's draw this. You can think of this as our garage, and then at the garage roof, okay, let's think of that. So this is the roof, and there's a person here. Okay, the roof is 6 meters from the ground, so the distance of the roof to the ground is 6 meters. And then a rock is dropped from the garage from rest, so the initial velocity of the rock is 0 meters per second, and we drop the rock, which is with a height of 6 meters from the ground. Determine how long it takes the rock to hit the ground. Okay, so let's begin writing our given. Okay, so the given, so the distance between the roof and the ground is actually 6 meters. Moreover, the initial velocity of the rock is 0 meters per second. So what are they asking us? For first one, determine how long it takes. So that's asking for time, the rock to hit the ground. So the time for the rock to hit the ground. And then we determine the velocity of the rock as it hits the ground. So for B, we are determining the velocity of the rock. So we're asking for the velocity final. As for C, a second rock is projected straight forward. So there's a second rock. So this is our rock 1, and we have rock 2. A second rock is projected straight upward from the ground level, so from the ground, which means 0 meters. So this is our dy, 0 meters, the point of release here. A second rock is projected straight upward from the ground level the moment the rock was released. So when the rock at the beginning was released, it was also thrown up. So they both, it fell and it was thrown upwards both at the same time. The second rock had an initial upward velocity of 6 meters per second. So another given is the initial velocity for R2 for rock 2 is 6 meters per second. So this is for R2 and this is for R1. How long will this second rock take to reach the maximum height? So as for C, they're looking for the maximum height for rock 2. And then D, at what time after the release will the two rocks have the same height? As for D, it's asking at what time will the distance for R1, the distance for rock 1 will be equal to the distance for rock 2. So meaning as this fall, as it gets and this goes upward, at what time will their distance be equal? So meaning they are both at the same height, kumbaga. So the height between the two rocks would be the same. Parang ganun. At what time na yung height ng dalawa is parehas. Okay, so there's a lot going on, so let's begin solving this problem. Let's begin with the time it takes for the rock to hit the ground. Okay, so how long will it take for rock 1 to hit the ground? So we're looking for time here. We're solving for time. And they gave us the distance that the car or that the rock should travel. The distance from the ground up to from the rooftop to the ground is 6 meters per second. So we have dy. We also have initial velocity. So from the equation that we have, it is simply easy to identify that this is the equation that we have to use. Okay, and that is simply because we have all the information that we need. So dy is equals to the initial velocity multiplied by time plus 1/2 gt squared. And as you know, the rock 1 has an initial velocity of 0 meters per second, so we can remove that. And then just plugging in the numbers, we have that the dy, the height that the rock drop should be 6 meters, is equals to 1/2 negative 9.8 meters per second squared t squared. So we will have, rearranging the equation, t squared is equals to basically 2, that's from 1/2. We just have to multiply it by 6 meters divided by negative 9.8 meters per second squared. Okay, so that would give us, and then we have to square it both sides because this is squared, and that would give us t is equals to 1.1 seconds. So the time it takes for rock 1 to arrive to the ground is 1.1 seconds. Okay, so let's ask for 2. What would be the velocity of the rock? What would be the velocity of the rock? What would be the velocity of the rock as it reached the ground? Again, we basically know the distance, we basically know the initial velocity, so we can actually use this. because we know we're looking for the final velocity. But another equation that we can use is actually this, because we already know the time it takes for the rock to hit the ground. This is easier to use. We don't have to square. We know the acceleration of the rock. We know the initial velocity, and we're just looking for the velocity. So the velocity is equals to the initial velocity plus gravitational acceleration due to gravity multiplied by the time it took the rock to drop or to arrive at the ground, which is 1.1 seconds. So v is equals to 0. So that's gt. Therefore, v is equals to negative 9.8 meters per second squared multiplied by 1.1 seconds. So the velocity of the rock as it hits the ground is equals to negative 10.8 meters per second. Quite easy, right? So that's the velocity of rock 1 as it hits the ground. Okay. Now let's solve for C. As for C, what is the maximum height of rock 2? When, remember, we throw rock 2 with an initial velocity of 6 meters per second as we drop rock 1 from the rooftop 6 meters from the ground. So to identify the final distance, to identify the time. Oh, for question C, how long will it take the second rock? We're not looking for the max distance, or we are looking for the maximum time, the time. How long? How long will the second rock take? So that's for time. We're not looking for the distance, we're looking for the time to reach the maximum height. Again. So a lot of assumption that we have to do here. So we threw the rock upward, and the initial velocity of the rock is 6 meters per second. And I want you guys to remember, when the rock reaches the maximum height, the velocity here should be 0, because when it reaches the maximum height, it doesn't go up anymore. So the velocity should be 0. Remember that A will also be g. So we have the final velocity, we have the initial velocity, and we have the acceleration. So from here, it is quite easy to identify which one are we going to use, and that is still this one. So to solve for time, we just have to use this. Velocity is equals to the initial velocity plus gt. And since we're looking for time, we just have, and we know that the final velocity is 0. We can remove this as 0, and that would give us time is equals to negative VO divided by g, and that is negative initial velocity is 6 meters per second, and g is negative 9.8 meters per second squared, and therefore our time is actually 0.61 seconds. So that is for C. So it took a rock to 0.61 seconds to arrive at the maximum height. Okay, so that's for letter C. That's A, this is B, and this is C. Now let's talk about letter D. What time after the release will these two rocks have the same height? So what will be the time where the distance traveled by rock 1 will be equal to the distance traveled by rock 2. This is an important identification, because in this type of question, don't worry, you don't have this in your monthly exam. This is just knowledge and how to do this type of question. What we need to do is basically identify or basically create a equality between the distance of the two rocks. So for rock 1, we know that the distance traveled for rock 1 is dy is equals to VOT plus 1 half TGT squared. And for rock 2, the same thing. The travel for rock 2 would also be equal to dy is equals to the initial velocity time plus 1 half gt squared. But what we're looking for is the distance that the dy should be equal to each other. And another note that we have to do is that for R1, this distance, we can also have this as a difference between the final distance minus the initial distance for rock 1, which is equals to VOT plus 1 half GT squared. As for R2, the same thing. This distance can be separated into the final distance minus the initial distance for rock 2 is equals to VOT plus 1 half GT squared. And we need to do this because we are looking for the time that the distance should be equal, meaning their final distance should be equal to each other. So we have to transfer this d onto the other side, their initial distance. We have to do this because the initial distance for rock 1 and the initial distance for rock 2 is not the same. What we're looking for is that their final distance should be the same. But again, their initial distance are not the same because the initial distance of rock 1 is on the top while the initial distance for rock 2 is on the ground. So we cannot do inequalities immediately using just dy for both. We have to separate this between their initial distance and the final distance. The distance we are trying to equal is their final distance, not their initial distance. So what happens now is that for R1 you would have the final distance is equals to distance initial plus VOT plus 1 half GT squared. And the same thing, the final distance for R2 should also be initial distance for R2 plus VOT plus 1 half GT squared. What we can do now is we can equal these two for both sides, and that would give us initial distance for rock 1 plus the initial velocity of rock 2 plus 1 half GT squared is equals to the initial distance of rock 2 plus VO, the initial velocity of rock 2 plus 1 half GT squared. And now we can actually solve for t. Okay, the initial distance for so let's see. Sorry. Okay. So in this configuration, we have to identify our point of reference. Let's take our point of reference as the roof. So our origin would be, so the point reference would be the roof. So the roof would be equal to 0 meters per second, and the ground would be negative 6 meters. So the initial distance for rock 1 would be 0, and the initial velocity of rock 1 is also 0. So that left us with 1 half gt squared for, or basically 1 half negative 9.8 meters per second squared t squared for rock 1. As for rock 2, since we use this point of reference, our point of reference is the roof. Therefore, the initial distance of our rock 2 would be negative 6. That's negative 6 meters plus the initial distance, or the initial velocity of rock 2 is 6 also, which is 60 plus 1 half negative 9.8 t squared. Okay, and that would give us negative 4.9 t squared is equals to negative 6 plus 60 minus 4.9 t squared. So you have negative on both sides. So if we add negative 4.9 on both sides, we can cancel this. And we can transfer 6 on this side, which gives us 6 is equals to 6t. Just divide 6 and you would actually get 1 second. Okay, so for letter D, the answer is 1 second. So at what time after the release will these two rocks have the same height? So as rock 1 fall for 1.1 seconds, at 1 seconds before it reaches the ground, and for C, it took C about 0.1 seconds to reach its maximum height, I believe. Yeah, it means in this scenario for rock 2, it already reaches the maximum height, and then it's already going down. As for rock 2 is still falling down. Rock 1 it's falling down. As for rock 2, it's already has reached its maximum height, and then it's already falling down when its height is equal to the height of rock 2 or rock 1 as it falls down, because it for them to have the same height, it will take 1 second. Sa rock 2, kailangan niya ng rock 2 already reaches the maximum height at 0.61 seconds. So after 0.61 seconds maximum height, and it starts to fall back. So at about 0.39 seconds after it reaches the maximum height, equal siya dun sa height ng rock 1. So that's how you solve this problem. So this is more complicated, especially in D part. Do not worry, you won't encounter this on your monthly test. Pero the rest, for example, yung letter C na to, they're quite more easy, and it is easier to solve. You kind of like have to expect that in your monthly test. Okay, last one, projectile motion. Okay, so for projectile motion, a cannonball placed on a wall 20 meters above the ground. So we have a wall, and this wall is 20 meters above the ground. So that was the free fall, ngayon sa projectile motion na tayo. And we have a cannon. So let's think of that as a cannon. Okay, placed on a 20-meter wall above the ground. It shot at a 20 degrees firing angle with an initial speed of 17 meters per second. So let's think of this as the horizontal dun sa mismong cannon. And then it shot, yung angle is 17 or 20 degrees. And the initial velocity is 17 meters per second. Determine the time it takes for the cannonball to hit the ground. So determine the time it hits the ground and the distance from the base of the wall where the projectile lands. What is the maximum range for the cannonball? Okay, so let's write our given. So we were given dy is equals to 20 meters. So the cannonball is above the ground for 20 meters and the firing angle is 20 degrees and the initial velocity is 17 meters per second. What are they asking us? They're basically asking us three questions. Time it takes for the cannonball to hit the ground, so the time of landing. So meaning basically also the same with how long was the cannonball in the air? Because when it reaches the ground, it's not in the air anymore. So that basically the time of flight. And also they're asking for dx. And lastly, what is the maximum range? So max dx. They're also asking for dx max. Okay, so how are we going to solve this? Understand that when we release the projectile, when it reaches the ground, it landed not on the same plane kung nasaan yung cannonball. It landed below the cannonball. So I hope you guys understand that because the cannonball was above the ground. So when you throw something, yung range niya, you would have to measure the range from the base of the ground, not here. Kasi magkaiba yung distance nito from here because it has to travel longer because it's a projectile. So I hope you guys understand that. But first, let's solve for how long will it take for the cannonball to reach the ground. So you have to consider that again that the cannonball will have to land on the ground. Hindi sa ere, dapat sa ground siya. So it is below the cannonball. So what that means is there's a height difference between the landing and the point of release or the point of launch of the cannonball. There's a height difference. So and this is very important distinction kasi yung kailangan natin gamitin dito is since we're looking for the time is since we were given the angle, we are given the initial velocity, and we have dy, as we actually have to use this equation right here because we're looking for time. Sorry. Okay. So let's use this equation again. As for dy, kasi meron kang difference from the point of launch and this is a point of landing. So the point of landing, yung dfy mo is equals to 0. Pero yung dito, so change in dy, so dfy is equals to minus d initial y is equals to voy t plus 1/2 gt squared. So yung final distance mo, displacement mo at the y-axis is 0. Pero yung initial height mo, from the point of launch is 20. So that should be negative 20 meters is equals to yung VOY. We should first solve for VOY kasi ang ginigay sa atin is initial velocity, but this is not VOY. To solve for VOY, we should take the initial velocity, the magnitude, 17, multiplied by sine, multiplied by the angle. So the VOY is actually equal to let's just go straight. So that is your VOY. So that's 17 sine 20 degrees multiplied by time plus 1/2 negative 9.8 t squared. Okay, so that would actually give you, yeah, negative 17. This is 5.8. Okay, so that would give you negative 20 meters is equals to 5.8 t plus, or this should be negative because that's negative 4.9 t squared. So that is negative 4.9 t squared plus 5.8 t plus 20 is equals to 0. So this is not a perfect square. You will have to use the quadratic equation again. Quadratic equation, and you'll be able to solve for the time. The time is actually equals to 2.7 seconds. So the time for the cannonball to reach the ground is 2.7 seconds. So let's solve for distance. So the distance traveled from the displacement is equals to velocity x multiplied by time. So first we have to we measure the time now, which is this one. It took 2.7 seconds for the cannonball to reach the ground. To solve for the distance it traveled on the horizontal, we just have to take first find ano ba yung velocity niya along the x-axis. And we know that Vx is actually equal to the initial velocity on the horizontal, which is Vox. And we know that Vox is equals to the initial velocity cosine theta. The initial velocity is 17 cosine 20 degrees, which is the angle of firing. And that is actually, so dx is equals to 17 cosine 20 degrees multiplied by 2.7 seconds. So the distance traveled is actually equal to 43.1 meters. So this is from the base of the wall to the landing area. That is 43.1 meters per second. So this is for basically distance. So we have time, we have distance. Now we are looking for dx max. One thing that you have to understand is to find the farthest distance along the horizontal na pwedeng makuha ng projectile, yung angle should be equal to 45 degrees for maximum distance along the tawag dito. Yeah, so yung angle of firing mo should actually be 45 degrees. And that means that would actually change yung ating time then. So, in order kasi na makuha yung dx mo, you need time. And you can only get the time by the vertical, by finding the time using the vertical equation. Kasi makukuha mo lang yung time using the y-axis, not the horizontal axis. So, let's find the time first. So yung dx max is actually equal to basically 17 cosine 45 degrees multiplied by time. Wala pa tayong time. So let's solve for time. So to solve for time, I basically have to do this same equation here. So we would have negative 20 meters is equals to 17 sine 45 degrees t plus 1/2 gt, which is negative 9.8 t squared. And this would actually give us negative 4.9 t squared plus 12.02 t plus 20 is equals to 0. Again, using the quadratic equation, you can find that the time is actually 3.6 seconds. Now that we know the time, we can substitute the time, 45 degrees multiplied by 3.6 seconds. So your maximum displacement is 43.3 meters. So that's how you would solve projectile motion. This part is the last part. You do not need to know this, but uh, your first part, time and displacement, be sure to understand how you do this because nasa monthly test you did siya. So that is projectile motion, and that's our last problem for this lesson. And I hope you guys understand what is happening. And if you guys have any questions, do not hesitate to message me. Thank you guys, and have a great day.